So we talked about how to get the powers on these terms. Now let's talk about how to get the coefficients. So we're going to use something called Pascal's triangle. And Pascal's triangle basically just has some numbers that we need to fill in. They're going to form a triangle when we do that. And at the top of Pascal's triangle, we're going to have a 1. Notice that it's the same answer that we got for doing a plus b to the 0 power. The next row of Pascal's triangle is going to have a 1 and a 1. And this is exactly the same as what we had when we did a plus b to the first power. When we get the next row, we're going to have a 1 at the beginning and a 1 at the end. And in the middle here, we get this 2 by adding the 1 plus 1 here. So 1 plus 1 is 2. So these values are the same as what we had when we did a plus b squared. So we had a 1, 2, and a 1, just like for what we had when we did a plus b squared. So if we want to square a plus b and get the coefficients, we could just use that row of Pascal's triangle. So to get this row, what we would do is start with a 1 and end with a 1, just like the previous rows that we had up here. And the middle values, we're going to get those simply by adding. So 1 plus 2 is 3, 2 plus 1 is 3. And these values are the same as what we got from just doing a plus b to the third power. So just to recap, to apply the powers, this row would be 0 power, this row would be to the first power, this row would be to the second power, that row would be to the third power. Now let's figure out what happens to the fourth power. So this row, as we know, is basically what happens when we raise everything to the fourth power, if we have a binomial raised to the fourth power. And to get these values, first of all, notice that we start with a 1 and end with a 1, just like in the previous rows. So start with a 1 and also end with a 1, just like the previous rows. To get the values in between, we're going to add. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and those are the values that we got for the coefficients when we raise something to the fourth power. So we could keep repeating this process to get the rest of Pascal's triangle. So 1s on the ends and add to get the middle values. So as an example, for this row right here, we have 1 on the ends and we got added to get the middle values. This is what we would get for the coefficients of a plus b to the fifth power. The next row, if we applied that process of putting 1s on the end and adding in the middle, we'd end up with the coefficients for a plus b to the sixth power. And if we repeat that process here for the remaining 2 rows, this next row are going to be the coefficients of a plus b to the seventh power. And the row following that would be the coefficients for a plus b to the eighth power. So let's use Pascal's triangle and the binomial theorem to help us to figure everything out here. So to get those coefficients, again, we're raising everything to the fifth power, we'll need to be on the right row of Pascal's triangle. The 0th row of Pascal's triangle starts with a 1. The power of 1 row has a 1 and a 1. The next row, we're going to keep a 1 at the beginning, a 1 at the end, and add those 2 values to get 2 in the middle here. So 1, 2, and 1 would be what we get for the second row. For the row that pertains to the power of 3, we start with a 1, we add those values, we get 3. Add these values, we get 3. And we put a 1 at the end, and that would tell us what the coefficients would be if we raised everything to the third power. So if we put a 1 at the beginning to get the next row, add those, that's 4. Add these, that's 6. Add these, that's 4. And then put a 1 at the end. That would tell us how to get the coefficients if we're raising everything to the fourth power. To get the fifth power, we're going to again start with a 1, add 1 and 4, that's 5, add 4 and 6, that's 10, add 6 and 4, that's also 10, add 4 and 1, that's 5, and then we're going to end with a 1 at the end. So all of these coefficients here are what we end up with if we're raising everything to the fifth power. So we're just going to fill these in. So 1, 5, 10, 10, 5, and 1 would be the coefficients that we're looking for. So let's see if we can apply our knowledge here to a different problem.